Hello everybody. In this video, I want to try to explain the difference between the logical deductions made in situation 32 versus situation 33 as per student request. And the confusing bit about this is that the scenarios in both of these cases are almost identical, right? We have this game where we're supposed to distribute these jellyfish into tanks, and the rule, put it in red here, for each one is the same. M is in tank 2 only if N is in tank 1. 33, M is in tank 2 only if N is in tank 1. So why is it that given these situations that we have entirely different deductions, valid deductions that we can make from those scenarios? Okay, so here's what we're going to do. The key idea, very importantly, is that we have a different number of tanks. Actually, well, let's do that backwards there. Okay. We have 3 tanks in 32 and only 2 tanks in 33. So let's explore why that would lead us to making different deductions. So before we do it, let's make sure that we're okay with, notice they both have the same first deduction. If M2, therefore N1, right? If M2, therefore N1. Let's put that in purple there. Okay. Let's think about how this, let's make sure that we're comfortable making that deduction first, and we'll go from there. So here's the idea. M is in tank 2 only if N is in tank 1. When you make a logical deduction, at least on the LSAT, what we're really doing is we're stating that if a certain scenario occurs, we'll just call it X, that must mean that Y happens as well. Now, the idea is there's only one path. If I place X in a certain position, that must lead inexorably to Y being placed in a certain spot. And that happens when we have this, right? M is in tank 2 only if N is in tank 1. So if we play the game, the idea that if I put M into tank 2, the only possible way that happens, the only thing that can occur in order for that to happen is N has to be in tank 1. So we have that scenario right there. Now, actually, let me just clear up a little space here for a second. Okay. Hopefully, pause the video if that confused you, but we should be clear that this is a valid deduction to make from that statement. Now, also equally important, whenever you make a logical deduction, an if-then statement, you can always derive a contrapositive. And the contrapositive really just works. Google it if you're not certain, but Cliff's Notes here. You flip the terms and switch the signs. So I would then, the contrapositive would be N1, M2, and since both of these were positive here, we make them negative. So the contrapositive of that statement would be, not if N is not in tank 1, that must mean M is not in tank 2. Alright. Now, in game 32, or rule 32, they stopped there. They made no other deductions. Let's explore why that's the case. You can think about it like this. We have 3 tanks, right? So in any given scenario, if I place, let's just play with M just for a minute. This is going to go a little bit long, but the idea would be that if you hopefully after the end of this video, if you see a scenario where you have 3 options, you just immediately stop right there with your initial deduction, your contrapositive, and you wouldn't go any further. But let me explore for a moment why that's the case. So think about it like this. If I've got N, let's just play with N for a minute and see if we can make any deductions about where N would go. There are 3 possible places where I could place N. I could put N in tank 1, N in tank 2, and in tank 3. And theoretically, there are 3 different places where I could put the other piece. I could put M in tank 1, M in tank 2, M in tank 3. I'm not going to sketch that out for the other 2. I think this will be sufficient for a moment. But you just reflect on that for a minute. There are, if I've got 3 tanks, then wherever I place N, there's 3 different theoretical options where I could place M. Now, in order to make a deduction, a valid deduction, if I have to just have one path. So, if I place N, to make some deduction about what would happen if I put N in tank 1, I'd have to eliminate at least two of these different pathways, and then that would, of course, let's say I was able to eliminate that it would be a violation if M is in tank 1 and M is in tank 2, and that would force me to conclude, oh, okay, well, if N is in tank 1, the only place M could go would be in tank 3. The big question is, can we make that deduction? And the short answer is no, we cannot. And here's how you can do this. This is just very practical, very matter-of-fact, and straightforward. Let's go back to the purple for a minute. Given the rule, here were the two deductions that we made. The actual deduction and its contrapositive. Now, I'm going to put it in yellow. This is critical. So make notes of this, if need be. You can only make a deduction with the left-hand side of the arrow. It is very, very seductive to think that, oh, look, I've got N1 over here, and it's tied to M2, so therefore, if I start off the situation with N1 over there, then I can make some kind of deduction about where M could go. No, you cannot. No, absolutely not. Nada. I am only allowed to make a deduction if the piece that I have right here matches one of those pieces over here. And N1 does not. Right? I have something for when we don't have N1, but, well, what does that mean? Well, then I still have a couple of options. I still have N2 and I have N3. There's really no deductions I can make. So we can't make any deductions about what happens with N1. And the same logic goes for N2. N2 does not exist here. Nothing we can deduce about N2. What about N3? Nope. And the same thing goes. We made a deduction about M2, but what can we deduce about M3? Nothing. What can we deduce about M1? Nothing. We have to stop. And that's why they concluded that the only thing that we can deduce from this scenario here is the rule itself and its contrapositive. And we have to stop. Okay, but now let's explore why this game here, is different. The fact that we have two tanks. Now, before I get into it, this is going to be kind of your takeaway here. If you're taking a test and you have a situation where you have a binary choice, right? I have certain players and I have only two options about where to place them, guaranteed you can make additional deductions. And let's explore why. We'll show why this is different. So, okay, the first things first. We can make the exact same deduction here. M is in tank 2 only if N is in tank 1. So I can say M2 happens if that situation occurs, therefore we must have N1. Right? And we can make the contrapositive. If not N1, not M2. This is where I think that the text is poorly constructed / confusing. I don't know why they did not put the contrapositive in here. That is absolutely always a valid deduction to make following some initial deduction. So they should have put that in there. Right? We should have M2 to N1, well then therefore not N1, just like the first game. The real question is why, how did they get this deduction here? They deduced something about N2. They said if we have N2, we must place M in 1. Well, let's see how they did that. Okay, so let's just look at this for a minute. Now, with two tanks, let's look at this. We have a couple of options. Let's start with M just for a moment. If I place M, if I place M in tank 1, there are two different possible places where I could place the N. I could put it also in tank 1, or I could put it in tank 2. Can we make any kind of deduction here? In other words, when we think about deduction, we think about, can we eliminate any of these paths? Would we be forced, if we put M in 1, are we forced to put N in one specific space? And the way we do it, always, banging my table for emphasis, is we look to the left of the arrow in our hypothetical situation, and we look at what we're given to the left of the arrow here with the deduction that we made from that information we were given. Does M1 appear there? No, it does not. We know what happens when M2 M is placed in 2. We have no information about what happens with M1. So we can just scratch this out. We can't make any deduction about M1. Okay, let's move on. What about N1? Can we make a deduction about this? Let's see. So remember, our two paths would be, if I place N in tank 1, M could go in 1, or M could go in 2. Only two possibilities for M. All right. Well, do we have a deduction for N1? Nope. We know what happens when we're not in N1. We also know what happens when we're in M2, but we have no information about what happens with N1. So, no deduction there. Okay. But now here's the annoying bit. You're ready? Here we go. So we look at this. We'd say, okay, well, what about N2? That's our final possibility. N2, well, the options there would be M would go in 1 or M would go in 2. So we'd look at this and say, all right, let's just circle this in yellow again. Do we know anything about N2? On the surface of it, no, we don't. N2 does not appear there, right? We have M2 and not N1. But here's the key. It's binary. There's only 2 places where N can go, right? Tank 1, Tank 2. So if we're not in Tank 1, where do we have to be? We'd have to be in Tank 2. So just pause the video if this confuses you. I'm sorry, I get all excited about this. But think about it. Not N1 means the same thing as N2. If you only have 2 options, if I've got this tank and that tank, right? If that's tank 1, that's tank 2. And I know I'm not in here. Well, then there's only one other place for me to go. I'd have to be here, right? So we actually can deduce something about what happens if N is in tank 2, right? We know that if N is in tank 2, then that must mean that M is not in tank 2, right? Well, by the same exact logic, if M, put it in red, if M is not here, it has to be here. That's the only other place where it can be. So we can in fact make a deduction. We can say, if we have N2, that must mean M has to be in tank 1, right? I can do that. So that's where that deduction came from. And again, confusingly, I'm not sure why they didn't write this down, we can derive the contrapositive. We could say, right, flip the signs, if we are not in M1, that must mean we are not in N2. Okay. Hopefully this was helpful. But your big takeaway here, is that if you have a binary situation, right, there's only 2 options where something can be, and you know that they can't be in one of those options, it must mean that they are in the other option, right? If I make a deduction about what happens when N is not in tank 1, well, that must mean N has to be in tank 2, which means that I can make, I can just translate this and I can make a deduction about what would happen if N is in tank 2. I cannot do that if it's 3 or more situations, right? If I know something is not, say, in tank 1, well, there's 2 other possible places where it could go, so I cannot, there's not one path, there's not one thing that I could deduce about that scenario. Hopefully this was helpful. Let me know if not.